All right, so here's the second question of our exam. The second question reads, how many horizontal regions do the titration curves for the amino acid D, the peptide AD, the peptide DA, and the tripeptide ADA all have? Okay, so that's basically our first part. The second part of the question is, will any of these subjects, those individual amino acids and peptides, have completely identical titration curves? Excuse me. Third part, what technique or combination of techniques would you use to distinguish these subjects from one another? And the fourth part of the question, will the overall charge of any of these peptides listed above ever be +2? Okay, so that's not asking +2, +3, that's asking specifically, will they ever be +2? Okay, so the way that I'm going to tackle this question is I'm going to draw each one of these curves individually. So the first one I'm going to draw is for the amino acid D. And the way that I'm going to make this kind of simple on myself is I'm not going to draw the amino acid because I don't really care about that and don't really care about the structure of this. What I'm looking at is the overall charge. So I've got on the N termini 9.66, on the C termini 1.95, because I know that D is aspartic acid. My R group is 3.71. Okay, so I will draw this as condensed as I possibly can here. My y-axis is going to be pH. My x-axis is going to be OH equivalents. We've got 0.5, 1.0, 1.5, 2.0, 2.5, and 3.0. So I've got, boom, that's my 1.95. This is my 3.71. This is my 9.66. So my curve looks a little bit like this. So horizontal regions, I've got 1, 2, and 3. Okay, so I'm going to kind of keep a running tally here. D has 3 regions. Okay, now I'm going to do, and I might not be able to get all of these on one slide, so I'll do my peptide AD. Okay, so that peptide is going to look a little bit like this. So A on the N termini and D after that. So do I have an N termini for A? Yes, I do. That has a 9.71. Okay, so is that different than the N termini of D? Yes, it is. It's 0.05 difference. My R group for A is non-ionizable. My C termini of A, well, that's involved in my peptide bond, so I'm just going to draw that. My N termini of D is in that peptide bond. My R group, however, is 3.71, and my C termini is 1.95. Okay, so if you want to compare these two, well, they'll look pretty similar, and to answer the question of how many horizontal regions does AD have, it's going to have 3. Okay, so the difference is going to be right here. This is going to be 9.71 versus 9.66. So it would just be up ever so slightly. Now, and for that reason, I'm not going to draw that entire peptide. DA, on the other hand, okay, let's take a look at that. DA will look like this. D followed by A. We've got a peptide bond between those, so that's going to be one instance where I don't need to worry about my N termini and C termini respectively, but my N termini of the amino acid D, aspartic acid, is 9.66. The R group is 3.71. The C termini is wrapped up in a peptide bond. The N termini of A is wrapped up in a peptide bond. The R group of A is not ionizable, and the C termini of A has a pKa of 2.33. Okay, so this will also have 3 regions because it has 3 ionizable groups. And in this one, the difference is going to be found right here. It's going to be 2.33, not 1.95. So that means that part is going to be up a little bit. Okay, now ADA, what will this look like? Well, I'm going to go ahead and, I've got my running tally here to go ahead and answer part 1 of my question. This is going to look like such. AD, peptide bond between alanine and aspartic acid, and then between aspartic acid and alanine. The N termini of alanine is 9.71. Okay, R group is not ionizable. C termini is wrapped up in a peptide bond. So then I jump ahead to my my R group of aspartic acid, which is 3.71, and alanine has a pKa on its C termini, because that's the next one that I actually care about. That has a pKa of 2.33. Okay, so this will also have 3 horizontal regions because there are only 3 ionizable groups. So to answer part 1 of this question, how many regions do the titration curves for all of these have? The answer is 3. Will any of them have completely identical titration curves? Now that question is not to compare. Arguably this is simply a yes or no question, so I'm looking for yes or no. And the answer to this question is no, none of them will. Because if you compare aspartic acid and AD, well then here, and I'm going to switch colors and I'm going to highlight my difference. My difference is not highlight. Yeah, I'm going to highlight it. My difference is that one right there. Okay, so this third horizontal region. Okay. Now, if you then compare AD and DA, well, do we have a difference? Yes, we do. We have a difference in the C termini. It's 2.33, not 1.95. Okay, so AD and DA are not equivalent to one another. Then, if you go to ADA versus DA, well, we have a difference in that this is 9.71 and not 9.66. Okay, well, where have we seen 9.71? I'm going to be drawing a bunch of arrows here. These are identical. These are identical. But these are not identical. Okay, so the answer to this second one, or the second part of the question, I'm just going to draw a line here, is nope. Well, I'll just put no to make it a little bit more professional. Oh, and I'm drawing a line straight through that. Let's see, I'll erase that. Okay, but my answer there is no. Okay, now the next question. What technique or combination of techniques could you use to distinguish these subjects from one another? Okay, well, all of these are going to have slightly different PIs, isoelectric points. So you could use IEF, isoelectric focusing, to separate them from one another. In addition to that, it would have to be very sensitive, but you're talking about a peptide, or a dipeptide, and a tripeptide, and a single amino acid. So you could use IEF and SDS page, because they're different in size from one another. And then add to that, you could also use gel filtration chromatography. I feel like GF has been kind of, whenever I see GF, I always think of gluten-free, but I just want to make sure nobody's thinking about this as gluten-free chromatography. It's gel filtration chromatography. Okay, so those are the 3 that you could use for part 3 of this question. Part 4 of this question is, will any of the peptides listed above ever be +2? Okay, now this is a little bit of a tricky question. Let's think about each of these groups. For aspartic acid, we have on the C termini a carboxyl group. So when that's fully protonated, that's going to have no charge. An R group, when that's fully protonated, that's going to have no charge. When your N termini is fully protonated, that's going to be +1. So aspartic acid, I'm just going to go ahead and keep a running tally of the most acidic pH, or most acidic charge. That's going to be +1. AD, okay, well again, we've got a positive, neutral, neutral, so that can be +1. DA, this is going to be a positive, neutral, neutral, because that's not ionizable, neutral, so that's +1. And now ADA, okay, so that's +1, neutral, neutral. I'll keep running tally of the R groups, and neutral. So all of these are going to be +1. So my answer to this question is no. So essentially, what I'm looking for in terms of the answer to this, the correct answer to this, which I'm going to break this down into 4 parts, each part worth 1/4 of a point. I'm looking for 3, no, IEF or SDS page, or gel filtration, I almost said gluten-free, or gel filtration, and no. So if you answered that kind of sequence, then you get full credit for this question. I hope this is helpful.